Hello, uh, good evening. Now, in this lecture, we are going to solve some example on signal flow graph. Already, we have discussed how to form the overall transfer function from the given signal flow graph. Now, you know all about the signal flow graph, and rest of the thing, when we will solve the problem, automatically the theory will be again revised, right? So here, what I have taken one example of a block diagram, that is the systematic representative of a signal system. This is your input, this is output, and all these blocks, error block, summing block, takeoff points, all this block you know. Now, as we have discussed, first of all, what we have to do, we have to just draw the first step is to draw the signal flow graph. Draw the SFG corresponding to this block diagram. How to draw the SFG signal flow graph corresponding to this block diagram system, block diagram of the system is that you have to take all these takeoff point and summing point, individual all the takeoff points and summing points and input and output. These are treated as the nodes, right? So we will take this, like this is your input, or this is a single node, and this is one summing point. See, we are considering this is one node and this is one takeoff point. So this is another node, this is one takeoff, sorry, this is your summing point. We are taking this is as another node, and this is the takeoff point. We are considering this is another node, and this is also summing point. This is another node, and this is your output, so that is your C. So we have considered all these points, like takeoff points, summing points, all these things as the nodes. Now, once the nodes have been defined, selected, next is to joining these nodes with the branches, right? So here to here. So this is your input goes to this summer. So definitely this branch gain is 1 because these and these two are in the same node basically. But to separate out this, we have considered this as your input node, and this is having the branch gain 1. Similarly, when we will go from this node to this node, what happens? This will be having branch gain of G1, right? And next, this point to this point, so these 2 points will be having gain 1, and next this node to this node, the branch gain is, you say this is your G2. Next this node to this node, what happens? This is, you see, a branch gain is 1, and again here to output node, this is also you will be getting branch gain at 1, right? So this is one, all the nodes have been incorporated and some of the branch gains we have already written there. Next, what you see, we will just remove this part to get some space. So now see, this is, so maybe this is your A, this is node B, this is node C, this is node D, this is node E, and this is node F, right? So these are the nodes we have considered here. Now from B to E node, from B to E, so this is your R, and you may call it A, this is your B, this is C, this is D, E, and this is your final node F or C, we may call it. And you see A to B, this is a branch gain G1 node formula. B to E, there is a path or branch which is having gain G3. So you have to just move from B to E, B to this point. Now see, this sign is positive, that means the branch gain is G3, is a no problem in it. Next, D to A, D to A, so there is a path or branch, okay, D to A. And D to A, you see, this is negative feedback. That means already in the last class we have discussed how to manipulate this symbol. That means if this is minus, that means this can be treated as positive with minus gain. So as there is no such positive and negative in this node conception, so what you have to do, you have to consider this gain is negative. That means if this is minus h1 and this is plus, so the same thing happens. That means this can be modified like minus h1 and this can be positive, the same thing. So that is why we can write this signal flow graph is like this. And you see C to F, C to F, or here you see to E, same positions. There is a note F, so C to F, C to F, also the same type of you see branch exist with gain. Automatically this will be minus of H2, right? So this is the signal flow graph corresponding to the block diagram. Now once you get the signal flow graph, but by using this node and branch and this symbolic analysis, what you have to do, we have to find out ultimately CYR, right? So CYR you have to find out, that is your overall transfer functions. And for calculation of the CYR, we have to take help of Mission's gain formula, right? Now we are going to get the Mission gain formula. So first of all, we will remove this part because this is of no longer use. So we are talking about the Mission's gain formula. Then Mission's gain formula, that formula we are already aware of, 1 by delta summation of, sorry, this is K, Pk delta K, with all these terms of usual meaning. So first of all, we have to find out the number of forward path, step by step, how to solve this analysis or solve the problems related to the signal flow graph, that I am going to discuss. So first of all, the step 1, I call it step 1, find the forward path, number of forward path. Okay, so number of forward path, that is denoted by K. So number of forward path means, what do you mean by this forward path? Already we have discussed. Still I am repeating this term. Number of forward path means the path from input to output, right? So this path, you see, from R to A to B, B to C, C to D, and D to C. Ultimately this is your first forward path, straight way from R to C. So this forward path consists of branch, like this is one branch, this is one branch, this is one branch, and like this. So what are the different branches? Gains are there, branch gains are there. So number of forward path, you see this is first forward path. And is there any forward path? Yes, see this, you are moving same directions to C. You cannot take this path because this is the opposite directions branches. So you have two forward path. Okay, so K will be having two value. That means you will be having, definitely this formula will be modified. For this case will be K is equal to 1 to 2 P delta, sorry, Pk delta K, that is 1 by delta, I can write is P1 delta 1 plus P2 delta 2. Now once you get number of forward path is equal to 2, next step is to find out the forward path gains. So first forward path gain, this is equal to first forward path gain. First forward path gain means the first forward path consisting of the branches, and the branch gains will be multiplied. So 1 into G1 into 1 into G2 into 1 into 1. So first forward path gain is G1 into G2. Definitely there will be second forward path, as you have identified. The second forward path is like this. Okay, so what is the path gain corresponding to the second forward path gain? This is second forward path gain. Okay, so what is this? This is equal to your 1 into G1 multiplied by G3. So G1 into G3 is the second forward path gain. Okay, so you get P1, P2. What else you have to find out? You have to find out first of delta. So delta, if you can find the delta, then automatically delta 1 and delta 2 will be found out, that we have already discussed. So what is the value to be found out for calculating the delta? Delta is related with the number 3. We may call it number 3. Okay, so this is delta. Delta is equal to, I may call 1 minus sum of loop gains of individual loops. There may be a number of loops. So to actually keep in mind the formula, I can write like this: 1 minus L1 plus L2 plus L3 plus and so on. So such that these are the individual loop gains plus what is the next part? Next part was the all possible combinations. That means the sum of gain products of all possible combinations of two non-touching loops. That means there may be L1 L2 plus L2 L3 plus L1 L4 and so on, depending on the number of loops, minus L1 L2 L3 and so on. What are these? This is the gain, sum of gain products. Sum of gain products. Gain products means L1 into L2. This is the gain products plus L2 L3. That means the sum of. So sum of gain products of L1 into L2 L3 L1 L4 and so on. Similarly, sum of gain products of all possible combinations of three non-touching loops. So three non-touching loops mean in the case you have to consider the gain products of three loops which are in not touching or not sharing the common node. So L1 L2 L3 L1 L2 L4 and so on. So this is the delta. So to find out the delta, what you have to do? You have to find out the number of loops. So next step I can say it, step 4. So step 4 is to find out the number of loops, number of individual loops. Say I can just try to find out the loop. Loop means that starts from originates and terminates at the same positions, right? So we'll start from A. So say arrow in this direction, we are going and going back to these positions without traversing a single node twice. So this could be 1, that is L1, right? And another, I will see this term, but this is directed in this direction. So this is not the concept of loop. That means this is not coming back to the originate position. So this will not be a loop. So this will not be a loop. Next, you start from C. You see G2 1 and coming back to this. Okay, so this could be the loop 2. Okay, and is there any other loop? Can it be possible? We can check it. See, from these positions, if you go like this, you can go to this, you can go back to this, but this arrow is directed from there to there. So that doesn't mean that this will form a loop, or in any case, no. So that is not possible of any loop. So there are actually we get two loops, right? We get two loops. We might call it L1. L1 means the loop gains. What is this? G1 into G2 into minus of H1. So minus G1 minus G1 G2 H1. This is the first loop gain. And similarly, you get the loop 2, that is G2 1 and minus H2. So minus G2 H2. Okay, this is minus G2 H2 and this is minus G1 G2 H1. So these are the two loops. Now once you get the individual loops, next step is to find out whether the possible combinations are possible or not. So we may call it, this is delta is equal to 1 minus L1 plus L2. If the two loops are possible, then two possible combinations is only one possible, if possible, L1 and L2. So combination is L1 and L2. L1 and L2, see, L1 is this and L2 is this. That means they are sharing the common node. So L1, L2, this is the possible combinations of two non-touching loops. Two non-touching loops is not possible. Not possible. So L1, L2 is equal to 0. That means L1, L2 will be equal to 0. So ultimately what you get, delta is equal to 1 minus L1 plus L2 plus L1, L2. This is the ultimate formula. From this generalized formula for this particular problem we get like this, and L1, L2 is 0. So delta becomes 1 minus L1 plus L2, right? So this is the formula for delta. Now if you put the value of L1 and L2, you get the delta. So this is the generalized delta for this problem. Now so delta becomes 1 minus, that means this is minus and minus, plus G1 G2 H1 plus G2 H2. This is the expression for, you can write it as the expression for, so this is the expression for delta we get, right? Next, what we have to find out, we have to find out delta 1 and delta 2, because according to Mason's gain formula, delta 1 and delta 2. So delta 1 and delta 2 will be found out. And so what is the value of delta 1? Delta 1 is equal to that part of the delta, that means that part of the delta which is in not touch with the fast forward path, because delta 1 we are considering the delta 1, that means for fast forward path, fast forward path. For fast forward path you have to find out delta 1, and this is your fast forward path. See, this is your fast forward path. So this forward path is in touch with L1 and L2. That means the fast forward path is touching L1 and L2. So if it is touching L1 and L2, so L1 will be 0 and L2 will be 0. So delta 1 will be equal to 1 minus 0 plus 0, that is 1, right? For second forward path, we will have to consider delta 2. So delta 2 will be equal to this 1 minus, now delta 2 is this. See, this is again touching with all the loops. This is the path where it touches L1, and again this is the path where it touches this L2. So here also it is touching L1 and L2. So this case L1 is equal to 0, L2 is also equal to 0. We get 0 plus 0 is equal to 1. So delta 1 and delta 2 equal to 0. Once delta 1 delta 2 is equal to 0, now T, that is the overall transfer functions, 1 by delta. 1 by delta means 1 plus G1 G2 H1 plus G2 H2. This is delta summation P1, and P1 already we know, this is your P1 G1 G2. So G1 G2 into delta 1 means 1 plus P2. P2 is your G1 G3. So G1 G3 into 1, right? So this is your overall transfer functions obtained by using the signal flow graph, right? So it is bit easier to get the transfer functions by using the signal flow graph, right? In the next lecture we will consider direct one example of signal flow graph, and from the signal flow graph we will consider again to we will find out the transfer function by using the Mason's gain formula, such that this all the concept of loops, all the concept of forward path, all the concept of finding out this delta 1, delta 2, delta 3 will be much more clear to us, right? Okay, thank you.